Well, we're excited to be back here building solar wall number 2. We already built one at the building by our cabin. You might remember that if you've already seen our couple of videos on it, but it's a great way to passively heat these buildings. And we have long, brutal winters here in Minnesota, so heat is an important thing. And the first one is working so well, we definitely decided to do it again on Ryan's new shop back here at our build site. But we learned a lot of lessons with the first one, so we made some tweaks, and I think this one's gonna be pretty darn sweet. So we're bringing you along the way as we get it built, and hopefully it'll go together quickly. Want to get us up to speed on what you've done so far in the building process?
Yeah, absolutely. When we framed this out, we knew we were going to do the solar wall here, so we framed out some extra studs every 5 foot on center to hold this Durock, which is our heat sink here. Hung it all, and then they insulated right over it when we insulated the shop. So it's all framed out and ready to go. The structure's there. So what I'm going to do now is I'm going through and I'm cutting out all the holes for the vents, top and bottom, tape the whole thing off, and I'm going to shoot the whole thing in flat exterior black, and then start putting my metal framing on there. So I'm pretty excited to get this moving. We've had, I don't know, the average temp in the shop has already started to drop pretty good. It's winter's coming early this year and we got to get ready. These are all the vent holes that we framed in here earlier before we foamed. So this is going to be the air intake, and then the air exhaust where the fan goes is up there. And we just sheeted right over it. And so now we got to go and find these holes and cut them back out. What I'm doing is I'm drilling the corners, and that shows me where they're at. And then I go to the other side and mark it, and then I'll come back. I got a ceramic saw on an angle grinder that I'll just cut it all out with. Okay, so here are my holes. I did both opposite corners. One thing I'm doing though, the bottom of my frame is going to be right here, and I want a little bit of ledge for a reverse air flap to sit on and have something to go against. So I'm going to come up an inch from the bottom, and I'm cutting up here. I got to do that about 14 more times. Okay, so I have all these vent holes marked now across the bottom, and I went around and I added some extra screws around them. This Durock is not super structural on its own. I didn't want it to vibrate and crumble and fall apart, so secured them all. Next step is to take this angle grinder with a masonry blade on it. This is a wet, dry cut masonry blade. I've used this bunch on tile and any cement type product. It works really well, so I'll go and I'll trim all these out, and then I'll be ready to start taping and painting. There it goes.
Woohoo!
Okay, so I got the rest of these cut out, and then I went around the backside and put plastic on the backside. I don't mind if I shoot some paint into these areas, especially up top where you will potentially be able to see it up there, so I want to be able to actually get paint into that opening. Next thing we're going to do is start taping off windows and the siding, and just get all ready to shoot paint on the wall.
Yeah. We got everything taped off. And so now what we're going to do is we're going to spray it with some paint. I have
just one of these Graco 360s. This is the cheap one you can get. And then we're using exterior, it's a flat black exterior latex. So I don't know, this is supposed to be a better one. I am kind of worried about UV resistance, and I was asking around at all the paint stores, and everybody's eyes kind of glazed over when I asked them, well, which one has the best UV resistance? So we bought the one that just looked a little nicer at Menards. We'll see how it goes. I mean, at the end of the day, we could always take the panel off and reshoot it in 10 years if we have to. But so yeah, I bought 2 gallons of it. Hope this stretches. We got 2 gallons and we got a little bit of the old stuff left. So we'll just start shooting, see how we do. Oh, nice. Start off with a mess.
Yay, first coat done.
Yeah.
You tired. What a big J.
Well, shoot.
This won't take long.
No, those All right, the paint is on. It went okay. My only real complaint in hindsight, which is funny because I've already done this another time, but these little pockets didn't take the paint perfectly everywhere, so I wish I would have shot it from multiple angles instead of kind of repeating myself. I learned it up top. I did better up there, but the next step now is to start installing the frame on top of the cement board. What we're using here is some aluminum extruded shapes. This is 1.5 by 2 inch aluminum box tubing. I bought this at a little local metal store. I bought a whole bunch of it. It came in 24-foot sticks, and we're going to pre-drill and screw this to the cement board. We'll do the sides, and then we'll do every 4 feet, and then we'll put our 4-foot greenhouse panel on top there. This will create our 2-inch air gap that the air can flow up. You know, somewhere right around here will be the next one, so the air can flow up here, go into the vent port, and heat the shop. So the next step now is to cut the angles on the end and then pre-drill where the screws are going to go. We'll do some silicone to seal it. We want there to be no air to be able to get around this, water to get in, so there'll be silicone between here and the wall. There'll be silicone between here and the steel on the side to keep water from getting in that way. And we'll install all this all the way down, and then we'll start thinking about putting on the greenhouse panel. Awkward. That just goes right through there. Okay, we're back. It's been a few weeks. We had some nice dry weather, so we were out doing other things, but temperature dropped beyond freezing last week, and we really need to get the heat on out here, so we're back working on it. I was doing some measuring. I think in the last time we were doing this and we were talking, we said the next part is to put all the vertical steel pieces in, the cross pieces, and we're just gonna get it all the grid up to put the greenhouse panel on. So I was out here doing measuring, and I realized in my design, when I was laying all this out on the computer, my intention was for every 4 feet for there to be a vertical piece of aluminum. That's what the greenhouse panel gets clamped to. And I intended for that to line up right against the side of the window here. Somehow my estimation or math was off, and I got an 1.5 inch gap. So first thing we got to do is go ahead and make a filler piece that fits the side of the window, and then once we get all 3 of those on, we can start putting all the main vertical and the top piece on and start filling this out, and that should go pretty darn quick. So excited to get a lot done today. The goal today is really to get at least a few sections done where they can start producing heat. I don't have to have it all done for it to work, so if we can get, call it half or something, get a good chunk of it done, it'll start getting some heat in the garage or the shop here, and that'd be great.
Should I set it up now, so you have something to put it on, or I wait?
Set it up and then tip it to the right, so then you can tip it to the left to have it in place. Now that we have our frame on the wall, we're going to start creating the clamping mechanism to hold the greenhouse panel down. And on our previous solar wall, what we did is we just drove screws right through the greenhouse panel, and that works, but I don't like putting holes in the panel. It provides a place for water to get in, provides a place for potential cracking and failure in the future. So the idea I had is we're going to take some of this extruded angle, and we're going to go ahead and I bought a non-ferrous blade or saw blade to put in the table saw, and we're gonna go ahead and rip a chunk of this off, and then it's gonna be, maybe that tall, and we're gonna put a screw through here, so when you tighten it down, it clamps over on the greenhouse panel that's gonna sit through here. And then there's gonna be some like weather stripping on here and on the other side to seal it all off. It's getting exciting. We got the frame on the wall here. Katie went through and put all these backdraft dampers on, so this is so that the air does not draft backwards at night. So it's just a piece of 6mm plastic, and then we put this weight on here. This bar is both a weight to keep it so that it falls back down, but it also is going to give it some rigidity so it doesn't get sucked up into the greenhouse panel and pinch and get held up. So Katie made all these yesterday and got them up. So what we're on to now is the clamps. This is the clamp mechanism that's going to hold the greenhouse panel on. So you saw us on the table saw. We were ripping this 1.5 inch by 3/16 angle, and we ripped it down to about 1/2 inch on the bottom. It's going to give us, it's something like 5/16 to 3/8 of a edge right here. And then we put this is just weather strip on here. We got to pull the backing off of it. And then there's weather strip here. So the greenhouse panel will go in between this and this. When we screw this angle on, it'll hold the greenhouse panel in nice and tight. It'll create a weatherproof, leak-free seal without having to use silicone. We'll be able to take this back off if we need to service on the inside. Should be a good solution here. So we're gonna go ahead and start putting this first one on. Hopefully we only have to do this once. We may have to take it down, but I think it'll all work. We're using these Tech screws, so they are self-tapping, but we are not gonna self-tap with them. So these, we pre-drilled them all. It's kind of awkward and tough to see, but we pre-drilled them all. This is the size of the hole that we need on the base, so we're gonna go ahead and use these as our pilot, drill through to the base, and then we're going to come back and then drill out these holes so that the threads don't tap into it, so then they can pass right through and just create a clamp. There you go. I can't say how happy I am. This is doing exactly what it's supposed to be doing. Okay, we've come to a little bit of a decision point here. I had this drip edge made especially for the solar wall, and I had the dimensions made where it came right out and covered up, and it's just perfect. It's just going to cover the right distance so that the greenhouse panel can sit back here and everything. The problem is I can't screw anything in. I can't put the top support bracket in that's got to hold on to the greenhouse panel, the clamping bracket. So just made a decision, I'm going to cut this flat edge off and leave the top drip edge, and it will still hang over quite a bit, but more importantly, let's see here, we are up under the soffit, so I'm not too concerned about rain really getting on this thing. But even if it does, we're pretty well sealed up. So unfortunately, we got 36 feet of edge here up on a ladder that I got all cut by hand, and it's not going to look great, but we're 14, 15 feet up from the ground here, so no one's really going to see it. It's just unfortunate, but sometimes even the best laid plans don't work right.
And Tucker's our supervisor for today. He is about 3 weeks out from having another knee surgery. He had his first knee surgery on his right side last spring, and then he blew out his other knee. So he's still in recovery mode. We have to keep him tethered to the side-by-side so he doesn't go anywhere. We can't stress that knee yet, buddy. But he's doing really good with his recovery. Hooray! So this next part is installing the track on the very top, which requires me to go on a super high ladder with Ryan. Not a big fan of heights. We'll see how it goes.
Okay, it's an exciting day. I have been working on these verticals and these rest of these hold downs off camera because it's kind of slow and tedious, and really it's taken a lot of time. We got four of these zones ready to go. We're ready to put some greenhouse panel up because each one of these zones will work on its own. So if we can get the greenhouse panel up, we can actually turn on that zone and start creating some heat, which we're in desperate need of. So today, that's what we're gonna do. We're gonna actually start cutting and putting in greenhouse panel. Hopefully it goes fast, but like the last 4 times we worked on this, we said we were gonna put greenhouse panel up today, and then we haven't done it. So, I don't know. I guess keeping the expectations realistic at this point.
Yeah, we'll see.
We'll get something done.
I have to remember.
This is Thermoclare 15. This is our greenhouse panel we're using. This is a dual wall greenhouse panel. I think it's called Thermoclare 15 because it's a 15-year warranty. It's a good Lexan product, and they do have triple wall stuff that has better insulation value, but you can see charts for the amount of light they pass through, and these are a pretty good trade-off between the amount of light it lets through and the amount of insulation it does. Exact same stuff we put on the other solar wall, and we've been very happy with it, so it's what we're going to use here. It is 4-foot wide sheets. They're slightly over 4 feet, and then we bought them in 12-foot lengths. We're going to be cutting both the width and the length down a little bit, and then we're going to be sealing the end with this foil tape. This is just standard aluminum foil tape, just for sealing up ductwork and stuff. So we'll put that on the top and the bottom, and we will poke holes in the bottom on this. On the last one, we used some shapes that you can buy to seal the top and bottom, and I actually completely sealed the bottoms off. For me, you know, you look at windows and they're sealed. The double windows are sealed. They're the best insulation you can do for a window, and they do vacuum all the air out of it. And these, you want them to breathe a little bit, which is a little counterproductive for insulation, but it does keep the moisture from building up, and we do have moisture issues in the other ones. So we will be poking holes in the bottom of this one. Someday I'd like to find a way to vacuum them out and seal them, but until then we're just gonna do it this way. This aluminum tape is behaving a little different than most aluminum tape I've used. It doesn't seem to be as sticky, and it's not really securing onto the bottom. So we started to poke holes in it here, and to me it's just not making sense why we do that. There's a nice air gap all the way down. I think we're just going to leave it like this. It can breathe out the ends if it needs to. And again, I think I mentioned this before, but this whole thing can be disassembled if needed. So if it proves to be a problem and we get condensation, we'll just come back and pop the bottom off and find a solution then. We could take the whole bottom off and get access this without taking the panels off, so I think we're just gonna head that way. All right. Kind of line up the holes where they need to be left and right, you know?
Got it. Okay. Yeah, it's pushing the thing down.
All right, can you kind of hold it and I'll go up there?
Yep.
So let's let the middle go out.
Okay.
There.
There's a ladybug inside one of those channels.
Oh, I know, they're done. Oh, it's doing it. Yeah, it needs to be sitting on top of that.
Ooh, it's a tight fit, but I think it'll work.
So it's working, the base is catching, and you can see it clamping over onto it.
That's great.
It's doing exactly what it's supposed to be doing. The panels are finally up. We got the frame done and we got the last of the panels up today. It ended up taking way longer than we had estimated. Drilling all these holes and prepping all this bracing and the frame and everything, and the covering strips just took way longer. I came out every morning before work for an hour just cutting and drilling these things to have them all prepped so that when Katie was available we could just knock it out. The one I'd say big disappointment I've had is I ordered clear panels, and we ordered supplies almost a year ago, and these are more of the milky white translucent panels. They do filter a little bit more UV, a little more light. I like them from the standpoint that they look better on the shop. They kind of blend in with the white side, and it doesn't make this such an eyesore, but it definitely is going to make them slightly less efficient. So again, since we made this so that it can all come apart, if we get into this and it's just not producing like we think it should, we can always come back and change the panels. They're not cheap. I don't want to do that, but it is an option. So we've had part of the panels done for, I don't know, a week or so. And on a sunny day, even without the fans in, I can see that the lower dampers are opening up and you can climb the ladder and there's hot air pouring out of them. So they're already, using Bernoulli's principle to pump. Bernoulli's principle? I believe that's it. So there we go. Somebody fact check me. But they are self-pumping, and so that is, again, the reason we're putting the fans up top. They're thermal switches. We're going to go talk about that now, exactly how the system's going to function, because it's fully automated. It comes on and off as the heat's available, as the sun is out, and then it shuts itself off when the area is cool so that it's not cooling the shop too. So we'll go show you how we set that up to that so that it works properly. Okay, here's how the electrical circuit's going to work for this. We're going to have a master switch, just a normal light switch to turn on the whole system. And then from there it's going to get wired to a baseboard heater thermostat. So this is designed to where it can handle full load, so it'll take 120 volts in and out. And it's designed to handle a couple thousand watts for a baseboard heater, so it'll run this just fine. From there we're going to a light sensor. And the reason is we only want this to run during the day. And on our other solar wall, initially we had issues with building getting warmed up during the day and then the sun going down, but it's still being warm enough in the building that the fans would run and it would actually start to cool the building off. So as soon as it gets dark, we want the fans to shut off so that it's not cooling the building. The problem with the outdoor light sensors is you give them power here and they only provide the signal when it gets dark, because they're made to turn on lights at night. And we want the power to come on during the day. So we are using a relay, and what the relay does is you give it power here, and we've wired to the normally closed side of the relay, so anytime it's not seeing a signal, it's going to give power. So when the light sensor is off, it's going to give power to our fans. When the light sensor comes on at night and gives power to these lines, it will shut off the output and turn on the normally open output, which we don't care about because we're not hooked up to anything, and so that will shut off the solar wall. The relay is reversing this switch. It's making its operation be the opposite. So now that that control system all sends power to the fans, it's day, it's cold, the fans are coming on. Here's the fan we're using. These are register booster fans. These are from AC Infinity. They came off of Amazon. And these are pretty fancy relative to your normal register booster fans. The purpose of these is to bring warm air to a cold room in a house that's furthest down your duct run. But these have some extra programming that we really like, and it makes it work very good for this solar wall. So like I said, they have a thermal sensor in there, so you can do some programming here, but you set it to where when it senses a certain temperature, the fans come on. But then what you can do is you can set a fan ramp. So the way we set this up is we set the temperature at 55 degrees. When the solar wall gets to 55 degrees, these things come on. And then we set a ramp all the way to 65 degrees so that the closer the solar wall gets to 65 degrees, the faster the fan runs. This keeps them from cycling on and off as, like say you just had a fan that was on a switch and set 55 degrees. It would kick on and then the solar wall would cool because it's bringing this fresh air in, and then it shut off, and you just be cycling the fans on and off all the time. These come on and they just find their speed that they want to run until it's fully warm in the solar wall, and they come on to full speed. So it's a pretty slick setup. These are actually DC devices, so there's a transformer on them. So we're going to make this 120 circuit run across the underside of these fans, and then we'll just plug them all in, and then once they're powered, they will run. The leads on this light sensor are pretty short, so I'm going to go ahead and extend them so that when I pull it through the wall, I can make it to my electrical box where I'm going to mount the relay. All right, it's the big day. We finished this up last night. We got it all wired up. We have a nice the sun just broke. It hasn't been sunny all day today, but it just broke, so we're ready to try this out. So I put an outlet on this switch, and I just have it plugged into extension cord for right now because we don't have the electrical done out here yet. But we're gonna go ahead and flip it on. I have the thermostat set for 70 degrees, and it's 50 degrees in here, so it should send the signal up to the photo switch, which should then send the power to the fans, and we need to program them as to what temperature to come on at, but we can go start setting that now. Let's flip the switch, see what happens. So I don't know if we're gonna be able to see anything. Yep, they just all powered up, but they don't know what temperature to come on at yet, so we're gonna go ahead and set that. Oh, this is awesome. All right, so we're gonna program this thing. You can see it's powered up, and it's reading 99 degrees in the solar wall, and I can feel the heat coming out of it. So what you can do is this can work for both air conditioning and for heaters. This is high temp, so it's trying to turn on when it gets warm enough out, or warm enough in the chamber. Low temp would be for running for air conditioner. And then I can set the temperature here. So what I want to do, I keep it 50 degrees in the shop. So I want it to kick on when it gets to 55 degrees in the solar wall. So it's pulling some heat in. But then what I don't want is for it to just go full speed. So what I can do then is set a transition temp of 2 degrees. So it turns on slow speed at 55 degrees, and then for every 2 degrees over that, it speeds up all the way up to speed 6. So once it's 12 degrees in, it's running full speed. So it's 98 degrees in there. It's gonna cool it down as it starts pulling fresh air through. But this, it's kind of a debounce function then, so it's not just running high speed, cooling it down there and then shutting off. It'll ramp up to speed as it warms up in the solar wall. And then the final thing I'm gonna do, I'm gonna go ahead and set the lighting down a little bit on that display. Like that, kind of dim it out a little bit. That's it, now it's set up to run. The final thing we have left to do is add some plastic flaps over these fans so that it doesn't backdraft at night, but we aren't gonna do that till we put the paneling on the wall this winter. It should be pretty quick, we should be getting to that. And then the other thing left to do is when I do the lighting in here, I'm gonna add a couple ceiling fans to circulate the heat into the room, since it's all gonna kind of be coming out around the ceiling. So those are the two real things left to do. Otherwise, it is up and running. It seems to be putting out heat. I'm excited to see, it started at 50 degrees in here today. It's already 52. We'll see how warm it really gets in here, just running for part of a day.
So that's it for this video. Thanks so much for tuning in, and we have another fun project coming down the chute. If you liked this video, you're gonna like the next one, and that is getting this place all wired up for real electricity. So we've been running the shop off of our little Opus, what do you call that again?
Solar generator.
Solar generator, and now it's time to do our real system. So the solar panels, the batteries, the inverters, all that good stuff. We've been working with Signature Solar to get all set up, and it's gonna be awesome. So stay tuned, we're getting ready to power that up, and we'll bring you along all the steps and how Ryan's wiring it up. It's gonna be 3-phase, so pretty cool, I guess. Anything you wanna say about that?
It's a big 3-phase system, so it'll be pretty interesting. I'm excited.
Yeah, he's very excited. So thanks again. Make sure to like and subscribe if you haven't already, and we'll catch you soon.